So why we need then power? Because it's very huge system and always it is subjected to some kind of disturbance all the time. If we'll see power system, all the time some disturbances are going on in power system, and it is very essential. We need the protection schemes for system as well as for elements that so that we can protect the system. So disturbance in terms of faults, disturbance in terms of change in load. Suppose a large load change occurred in the system, right? So at that time, how whether our system is ready to tackle this situation. These are very important issues, important aspects, because during the lockdown condition, the PM suddenly announced that 15-minute we should drop our load. That is a huge chunk of change in load. Please mute your mic, everybody. I request everybody should mute your mic. Whenever I will ask any question, you respond. Okay, please mute your mic. So that is also a phenomenon of large disturbance, or you can say a disturbance because of the change in load, because power system need to operate under the condition where the load is approximately equal to the generation. If it doesn't happen, if there is a large gap between load and the generation, then it is called a very huge disturbance. Okay. So therefore, because we know already the power system is subjected to disturbance, so though it is subjected to disturbance, so even if it is subjected to disturbance, but the gap between the load and the generation is very small. So therefore, we are not feeling that the power system, it's very dynamic phenomenon. So actually next semester also I'm going to offer a course in power system dynamics. In that we can study in that. That is an elective course. Whoever are interested, they can opt for that course. So this is how power system disturbances occur in the system, right? So um, the power system disturbance occur whether in terms of fault, whether in terms of load disturbance. So therefore we need the protection system, right? Okay, let us see next. Okay, this course evaluation already, it has been communicated by the academic section to all of you how to evaluate this course. This semester, because you are not here physically, and examination is very difficult to conduct, because this is this is the pattern I have chosen in the last semester. End sem exam 50%, mid sem exam 30%, industrial visit 10%, class test 10%. Because this time you are not present physically here, so we cannot have all this. We cannot have industrial visit, so this component will be removed. And rest, end sem and mid sem class test, all these will be based on your assignment or some kind of quiz. If possible, I will take some quiz on Kahoot or some other platform that is time based, and you have to perform based on the time, within the time limit. Okay, so your weightage of each of the assignment or examination, already it is communicated by the academic section. So I should not tell more about it. So only thing is we'll it will be a continuous evaluation. Like I'll send the assignments or whatever, some quiz may be conducted. So based on that, you will be finally graded at the end of this semester. Okay. And also attendance is mandatory for attending mid-sem and end-sem exam. So 75% is mandatory. So please attend all the classes or at least 75%. Okay. So next we'll see course content. What are the contents will be covered in this course? First we'll talk about the introduction. In this we'll talk about general introduction like fault analysis and and also about the system we'll talk. Then we'll talk about the CTs and VTs. What is CTs? CTs are the current transformer and VTs are voltage transformer. Perhaps you know, might be, these are all, we can say, sensors or transducers. Okay, sensors, or we can say transducers. Okay. In fact, they are required for sensing the current and voltage in the system, and which will be fed to your relay, and ultimately relay will send the tripping command to the circuit breaker. And circuit breaker is very useful in isolating the faulty section of the system. Okay. Then we'll talk about some of the attributes of protection system. Attributes in the system, that means we'll characterize how we can characterize the protection system or protection schemes. If suppose we are designing a protection system, how it will be evaluated. There are different attributes. We'll talk about this, like sensitivity, reliability, all those things. We'll talk about this in this section, in this content. Then we'll talk about the overcurrent protection. Generally, overcurrent protections are preferred in a distribution system, not in the transmission system. Why it is not preferred in transmission system, we'll talk about it with proper explanation. And generally it is preferred in the distribution system. So we'll talk about the overcurrent protection, different kinds of relays used in this kind of schemes. Then we'll talk about the directional overcurrent relay. Here we will talk about only overcurrent relay. Here we'll talk about the directional overcurrent relay, means it will sense the direction along with the overcurrent. Like as soon as the fault occurs at some portion, part of the network, the current increases suddenly, very huge value, and the network needs to be protected. So at that time we need to use the overcurrent protection. But what is the purpose of directional overcurrent relay? It will sense only in one direction. It will not sense in both the direction, because it has some drawback if it will sense in both the direction. Okay. Then we'll talk about the distance protection. Distance protection is always preferred to protect the transmission line. These two are preferred to protect your distribution system. I hope you know the difference between the distribution system and the transmission system, right? So I am not going to explain in detail. So distance protection is preferred to protect the transmission system. Okay. So we'll talk about more in detail about this. Then we'll talk about the relays. There are different types of relays based on the constructional features. Static relay and electromechanical relay. Electromechanical relay will not talk much. So we'll talk much in detail about the static relays and then the numerical relay. These two are very important because nowadays you will not find anywhere in the field the use of the electromechanical relay. Those are obsolete relays. They are not being used nowadays. Only nowadays existing is static relay and the numerical relay. So we'll talk about these two relays. Okay. Then what are the books we'll refer in this course? These are the three books I'll refer. The first book is your Power System Relaying by Stanley Horowitz and Arun G. Phadke. It is by Wiley. So all these three books are available in the web. You just note down and search it and you will find the soft copies. You can read it because you cannot access your library now. So you can access the soft copies from the web. So you can read it. Then the second book is your Fundamentals of Power System Protection by Thankar and Bhide. Then third book is your Digital Power System Protection by Bhide, S.R. Bhide. Okay. These three books we'll prefer, and these three books are available in the web. The soft copies are available. Please download it. Okay. So next we'll see some of the introduction. Then we'll close today's class. So we can see here what we are seeing here. We are seeing a fault that we call arcing fault. We can see here what we are seeing here. This is a transmission or transmission line, right? Transmission line, and the conductor is here. This is your line conductor, and these are your insulator strings. Okay, these are the string insulators. Generally, insulators are provided to give insulation between the line and the live line and the tower, because tower is grounded always. So therefore, and this is your ground wire, right? And so when there is over voltage or some transient over voltage may happen because of the lightning also sometime, or because of the switching in the network. And so therefore, because of the over voltage, that may be very temporary, that may be very up to millisecond or microsecond, but that produces the ionization of air across this. We can see here that produces ionization of air across this conductor and the tower. Okay. So because of the ionization of air, it forms an arc, and we call it fault arc. Okay. So that is the arcing fault. It is not the metallic fault. Metallic fault means it is directly in contact with the ground. That means your conductor, your open conductor is directly in contact with the ground. That is called the metallic fault. Okay. So this is called the arcing fault, right? So if we'll see the arcing fault here, The arcing fault resistance, that is R arc, is defined as this formula 8750 multiplied by S plus 3 ut divided by I to the power 1.4. This is the resistance. In fact, this formula cannot be derived mathematically. It is in fact derived through empirical analysis, right? Derived by empirical analysis. What is empirical analysis? It is in fact experimental analysis. Through experiment by taking the readings and matching the data, that is we call curve fitting. Through that method, it is through the, this is empirical formula derived through the experiments. Okay. So in this formula, what is S? S is the spacing between the conductor and the ground. Okay, this is S. This is your S. And plus 3 ut. U is the velocity of air. Okay, velocity of air. And T is the time for which the overvoltage occurs, right? Time for which the overvoltage occurs. And I is the current flowing through this arc. Okay, I is the current flowing through this arc, that is I. So through this we measure the resistance, or we calculate the resistance, arcing resistance. Okay. Now let us move. So this happens, we can see here how it is very dangerous, right? You can see the arcing fault. It is really dangerous. In fact, so much arc is produced, right? And because of this, what happens? Because of this arc, the insulator is burned, and the insulator in fact damages, right? So it is really dangerous. So we should always avoid this, right? So let us discuss about the faults and the abnormal operating conditions. So faults may happen because of the Shunt fault, or it may be because of the series fault. What is Shunt fault? What is series fault? Shunt fault is when your open conductor is being connected to the ground, that is shunt to to the source, that we call the Shunt fault, right? And what is series fault? Series fault, it happens in series of the line or series of the equipment. Okay, so that is series fault. So how these Shunt faults happen? It is because of the aging, temperature, rains, hail, snow, chemical pollution, foreign objects, over voltage surges, right? So aging means, suppose your insulator used, it became old gradually. So because of that, the quality of the characteristic of the insulator deteriorates, right? The dielectric property of the insulator deteriorates, and because of that also this happens. Then your temperature, because of the rise in the temperature, it also happens. And because of the rains, hailstorm and hail, and also snow, we know because of this it happens, because when the snow covers the insulator, then it is your conductor is short circuited to the ground, right? Then your chemical pollution. Because of the chemical pollution also your insulator deteriorates, right? Then the foreign objects means your something like your tree fallen down or something happened, right? Some because of some storm. So that causes the short circuit. And also over voltage surges as we discussed, right? So over voltage surges may happen because of the lightning or maybe because of the uh, switching phenomena, right? Then we'll see effects of the Shunt fault. What happens when the Shunt fault? Obviously, when the Shunt fault is there in the circuit, a high current flows through the circuit. And what happens because of the high current? That causes damage to the equipment because when the high current flows, excessive heat is produced. And because of that, the equipment in operation damages. Sometime in the field it has been observed that the transformers, the winding has been damaged. The winding was it was quite bent, right? And also the generators also similar thing, similar phenomenon happens. Okay. And also it causes damage to operators. Those are the operators in the system. Those are doing the operation. It also causes damage to them, or it has harmful effect on them. Then next is it causes the system stability issues. System stability issues means already I hope you have studied this basics of system stability. System stability I hope you have studied, right? Okay. So then how it causes the stability issues? Because of the rotor angle phenomenon, if you know, right? Already you have studied this. Let us consider a single machine infinite bus system. This is your single machine infinite bus system. Suppose the fault occurred here somewhere, right? So what happens then? Then we know that as soon as the fault happens, the electrical power output becomes 0, right? Why it becomes 0? Because we know that the electrical power is V1 V2 by X sine delta, right? Okay. One of the voltage becomes one of the, let us say here voltage is V1, here it is voltage V2. So one of the voltage becomes 0 as soon as the fault is there, right? So it becomes, so if we'll see the swing curve,
Sir, your voice is not audible.
right? This is your PM, this is your PE. Now, we know that this point is the initial operating point, delta naught, right? And when the fault occurs, this PE becomes 0. This becomes 0, then as PE becomes 0, your PM becomes greater than P and your rotor accelerates, right? So as the rotor accelerates, your delta increases. So this is rotor angle, so your delta will increase. Okay. As your delta will increase, if there is no protection mechanism, that is, these two circuit breakers will not isolate this fault, then it will go on increasing and your rotor angle of the generator will become unbounded. Okay. Unbounded means it will become out of step of the, or out of synchronism to the other, out of synchronism from the system, right? Okay. So as it will become out of synchronism, your system will become unstable, right? Okay. So if some protection mechanism is there, then if your fault clearing angle, suppose fault clear at this angle, then it can somehow it can become stabilized, right? We'll talk more about this in the later classes. Okay. Later classes we'll discuss more about this. So already you know the classification of Shunt faults, right? They are phase faults or ground faults. What is phase fault? What is ground fault? Ground fault is where only one phase and the ground is involved, then it is called the ground faults. Where other phases are involved along with the ground or separately, or only phases are short-circuited, they are called the phase faults. Okay. So it has been studied that there are different faults like line to ground fault, line to line fault, line to ground fault, line to line fault, and also another fault is line to ground fault, right? So out of these faults, we can see here line to line, that is the three phase to ground and three phase fault. They are called the symmetrical faults, and they are most severe. They are the most severe faults, if we'll see, right? They're the most severe faults, three phase faults, right? And the unsymmetrical faults like line to ground fault or line to line fault, line to ground fault, they are least severe. But however, the probability of occurrence probability of occurrence is very high in case of line to ground fault. Okay, it's around 85%. So it has been statistically observed that line to ground fault is around 85%, and line to line fault it's around 8%, and line to ground fault is around 5%, and three phase fault, that is the symmetrical fault, it is very less. The chance of occurrence of this three phase fault is very less. It's around 2%. It's very less. And if we'll see the power system elements, if you'll observe, the power system elements and the probability of fault occurrence, then obviously we will see it. The most of the fault occurs in the overhead lines. It is maybe because of the natural disaster, because of the uh, transient overvoltage phenomenon, because of the switching phenomenon, or because of the different types. So because of that, so most of the probability of the faults, the chance of fault occurring happens in the overhead line is the highest, that is 50%. And in underground cables, it's around 9%. And in transformers, obviously transformer is always connected to transmission line. So there is a little higher chance, that is 10%. And generators, 7%. Switch gear, 12%, right? And CT, relay, control equipment, all this, the fault in the protection system itself is 12%, right? This is all about the probability of occurrence of fault in different elements of the power system, right? Okay. So, okay, this is all about your first class. So next class we'll discuss more about these type of faults and fault analysis. Okay. So we'll stop here. This is your first class.